Hello, hello, friends on the internet. Today we're going to talk about the differences and how to use UTM, MGRS, and latitude and longitude. All right, so we're going to start with UTM and then we're going to go to MGRS and then we're going to finish off with latitude and longitude. So if you have a grid, we're using the UTM coordinate system, okay, and you're going to get a grid and it's going to look like this right here, right? The first numbers, right, 10s in this case, are going to be designating which chunk of the Earth this map is talking about, right? So UTM and MGRS split up the globe in a grid system, and then they pull each grid out, and then they put a grid on top of that block from the greater globe grid. So this 10s is saying that's the chunk of the globe we're looking at. So within that grid, that coordinate designator, right, we have a bunch of numbers. We can see our easting here. There's a little 7, and then on our northing, there's a little 43. And then, so those numbers stay the same. If you have a map in your hand, right, if you're looking at a physical map that isn't spread across an entire battle table, these little numbers are going to stay the same on that entire map. Cool. Yep, that's all I have to say about that. So for UTM, the easting has one less number than the northing for complicated reasons I don't care to get into. All you simply do to make this easy and simple is you add a 0 to your easting. A lot of applications and maps and whatnot have done this already. Okay, so if you have two small easting numbers and the first one is a 0, well, then they've already added that 0 for you. Okay, so as we can see up here in the location, the grid they gave us, right, in this right here, that 0, they did add a taint down here, but on the actual map itself, there is no little 0 in front of the 7 there. All right. So with UTM, a 4-digit grid gives you 1,000-meter block, right? Because that 07 never changes, and then that 43 never changes. So then we're really looking at 06 and 44, right? So this would be the 06 and the 44 right here. And that just gives you this 1,000-meter block, all right? And then if we want to go down to 100 meters block, we would then need to add in, what is it, a 5th and a 6th digit, right? So it'd be 07068 43446. That would be talking about a 100-meter block. And then if we added more digits onto that again, right, 2 more digits, the 070683 434468. Now I'm talking about a 10-meter square. And when we're talking about tactics and stuff like that, that's typically the accuracy level we're going at. I want to know where you are, or where the item is, or where the objective is within a 10-meter box. Sometimes we can add another digit to that like they did here and get all the way down to 1 meter, which is basically the actual person standing there. But it's when we get into the next stage of this and we start plotting points, it's pretty difficult and unrealistic to expect a human to be able to plot points to that precise level. So there's really not much of a point in worrying about it anyways. Just stick to the within 10 meters accuracy. All right, so that's UTM. Hopefully I did a pretty good job of explaining that. MGRS, if you are a military guy, is what you're familiar with. MGRS is actually just simplified UTM. So if you know MGRS, like I know MGRS like the back of my hand, I'm about to explain this to you in a way that unlocks UTM for you instantly, okay? So what they did with MGRS is they took UTM and they took all that confusing bit about the first numbers never change and the easting actually has one less, so you have to add a 0 there. Way too complicated for retard grunts. So they took all that out and they added a second grid designator. So not only do we have the 10S designator just like we had in UTM, but we get rid of that imaginary 07 and that 43. We throw those away and we add in CJ here. because for like a squad on patrol or even like a platoon or a company looking at their AO, it's going to be all within CJ. It's going to be all within 0743. So having these numbers there just confuses people. They throw them away. And so then they just go right into the next sets of numbers, right? So a 4-digit MGRS grid is the same thing as a 8-digit UTM grid, right? Because if we go from MGRS to UTM, we get rid of this GJ. That's a tongue twister. GJ. We get rid of GJ, and we add in 43 here to our northing, and we add in 07 to our easting, right? So 068446 in MGRS is actually 07068 43446 in UTM. Hopefully that makes sense. Cool. This website that I've been using is maptools.com, and we are in tutorials, and then here's MGRS quick guide, and this is UTM quick guide. Now we are going to go to what I'm least familiar with, latitude and longitude, and hopefully I don't mess this up for you. All right, so latitude and longitude is different than UTM and MGRS because UTM and MGRS are designed for people to walk around and be able to communicate grids with other people walking around. People aren't traveling 100 miles on foot in a day, right? So we've made some accommodations. We've gridded up the whole Earth, and then we pull up a grid and we give it a designator. Latitude and longitude just spans a grid all around the Earth, and there is no designator, right? So this can be used for ships and planes a bunch because they are traveling hundreds of miles in a day and whatnot. So rather than having to flip through a bunch of grid designators, it's much easier to use latitude and longitude that is just one grid system over the entire Earth. All right, latitude and longitude operates off of degrees, right? So there's, and then within a degree, there's 60 minutes, okay? So latitude is the measurement of distance north or south of the equator, right? So if this is the equator, the middle of the Earth, we could be 30 degrees or 60 degrees or 90 degrees north, or 30 degrees, 60 degrees, or 90 degrees south. Longitude is the measurement of distance east or west of the prime meridian, which is the center of the Earth going north to south rather than east to west, right? So we are either 0 to 180 degrees on the eastern half or 0 to 180 degrees on the western half. They're measured in degrees. The distance from one parallel meridian to another is 1 degree. Each degree can be divided up into 60 minutes. Each minute can be divided up into 60 seconds. So 29 degrees, right? And then to get more fine, we have 58 minutes and 31 seconds. That means 29 degrees, 58 minutes, 31 seconds. You can think of this as like feet, inches, and then fractions of an inch, right? So this is, 1 foot, 5 inches, and 3/8. Think of it that way, right? Those are numbers people actually work with. Or if you're not into like carpentry, we could bump it up one. It could be yards, feet, inches. So it's the same style of measurement, the same unit of measurement, but we are just getting more finite in the amount that we're measuring. All right. So the other thing that's different about latitude and longitude is in latitude and longitude, you get your northing first, which is your latitude, and then you get your easting, which is your longitude. And in UTM and MGRS, it's the opposite. You get your easting first, and then your northing, right? See, in this one, the 06, we're talking about east or west, and then 44, we're talking about north or south. But then in lat and longitude, they're swapped. An easy way to overcome this, they talk about right here, is to just annotate it, right? Whether I'm talking about latitude and longitude, right, then I'm going to say it's blah, 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 latitude, blah, 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 longitude. And then same thing for MGRS or UTM. I can give a grid designator and then say easting or meters east. and I can then get a grid designator and say northing or meters north. And that helps just clarify, no confusion. I don't have to trust that I said it the right way and trust that the guy on the other line remembers it the right way. I can just tell you, this is the easting, this is the northing. All right, that's a brief overview of UTM, MGRS, and latitude and longitude. This is LandNav Part 2, and in the next one, we will actually be working on a map and plotting points and getting a heading and measuring distance between points. See y'all then.